Hello, in this video, let's look at two special cases, one with no solution and the other one with infinitely many solutions. So the first example is the one with no solution. Let's see how that happens and how we can tell that it has no solutions. So we have a system of three equations, three unknowns, and we can cancel any one of those unknowns. So let's cancel the z. So we can use the second and the third to cancel the z. Then we have equations just with x's and y's. So if we use the if we add in the second and the third and cancel in the z, all we need to do is multiply the second by -1 and add them up. So if we multiply by -1, we get negative x minus z is -1, and the bottom equation is 2x plus y plus z is 2. And if we add these together, we have x plus y, and then negative z and z cancels off. -1 and 2 makes 1. Now we have two equations, two unknowns, and we can solve them. So if we put them next to each other, we can use elimination once again and cancel either x or the y and get the answer. At least that's a theory. So to cancel the x, we can multiply the second equation by -1, and we already see that there is something strange happening because the equations are awfully close to each other. They're very similar. Now if we add the two together, the x with the negative x cancels off. Y with the negative y also cancels off, giving us 0 equals -1. Well, there is no x, no y, no z to make it true. All we have is a statement that is never true. 0 is never -1. So when that happens, we know that there is no solution. And that is the end of the first example. Now the second example is the one with infinitely many solutions. That one will take a little bit more work because we have to write the final answer using the general form as opposed to just numbers. So here is the second example. We have system of 3 by 3s. We can cancel any letter, x, y, or z. Let's cancel the x. We will use the middle equation to cancel the x's because it's easy to multiply this 1x by whatever we need to cancel the 2 and the 3. So here below we have a setup where we have the middle equation with the first and the middle equation with the bottom, and we're canceling the x. So to cancel the x with the first, we can multiply everything through by 2 and add. So if we multiply, let's copy it over first and then we'll do the addition. 2x plus 8y plus 2z is 4. Multiplying by 2 makes 2x plus 12y plus 6z is 8. Adding them together, x's cancel off, and we get 20y plus 8z is 12. Now with the second equation, we also cancel in the x. We're multiplying the first by -3. That makes -3x. 3 times 6 is -18y. 3 times 3, -9z. And the other side as well, -12. Now we add in the two equations together and canceling the x. So that makes x disappear. -18 minus 2 is -20y. -9 plus 1z is -8z. And then -12 and 0 is -12. So we see our two equations, and if we write them next to each other, we see that they're exactly the same actually, because if we multiply the second equation by -1, all the signs will switch and we get precisely the same equation as the first, which means we have infinitely many solutions. If we were to subtract them the way they were, we would get 0 equal 0 because they're exactly the same, which is always true. And when you have always true, that means we have infinitely many solutions. Now we have to write the answer in general form. Now, the general form means we have to express our x, y, and z in terms of the letters. So from the equation that we have here, let's solve for the y. So the y would become 20y. To do this, we have to get y by itself and everything else on the other side. We minus 8z from both sides. And then we divide everything through by 20. Each term divided by 20. And reduce. Y is 12 divided by 20. We can reduce by 4. And that makes 3/5. Reducing the second by 4 also makes negative 2/5 z. So this is the y in terms of z. Now we also need the x in terms of the same letter. We can use any equation that has x. Well, let's use the one that has x with a 1 to solve for it, and then we'll have our expression with just z's in it. So solving this equation for the x, we will get x plus 6y plus 3z is 4. So getting x by itself, we minus the 6y and we minus the 3z from both sides. But we know that y is equal to 3/5 minus 2/5 z, and we replace it and simplify further. So the y is 3/5 minus 2/5 z minus 3z. Now we have 4 multiplying by negative 6, that's negative 18/5, plus 6 times 2 is 12/5 z minus 3. Well, the 3 is over 1 and we're combining it with the 5th. So we can multiply it up and bottom by 5 to get minus 15 z over 5. So that makes, and also here we have 4, so we can multiply it by 5 to get the same common denominator. And that makes 20 minus 18, that's 2/5. And then 12 minus 15 is negative 3/5. And that z, and that is x. So now we have the x, we have the y, and we are ready to write our final answer. Our final answer usually is in terms of x, y, z, only this time everything is going to be in terms of z. So the x in terms of z is 2/5 minus 3/5 z. The y in terms of z is 3/5 minus 2/5 z, and the z is just the z. And this is the final answer to our question in general form. We can also solve for a different letter and we'll have different expression, but they will describe the same exact points. And that is how to solve the two special cases, one with no solution and one with infinitely many solutions. If you have any questions, please let me know. Thanks for your time. Take care.